Hello everyone. In this video, we will dive into the word embedding. Word embedding is located in this part of transformer. Neural network, including transformer, can take input in the form of vector. Then, how can we input words into neural network? For example, we want to input the word hungry. In the simplest form, we can use one hot vector. For example, we have a collection of words that we will use in our model. The whole dictionary consists of 7 words like this. The length of each vector for each word is the number of the words in the dictionary, which is 7. Then, like its name, one hot vector, we put number 1 for one of the vector elements and the other elements are set to 0. For the first word, the first element is 1. For the second word, the second element is 1. For the third word, the third element is 1, and so on. Simple, isn't it? But the problem is there is no meaning on each word. There is no connection between the meaning of each word. For example, the meaning of chicken should more similar to the word duck in comparison to the word eye. But by using this one hot vector, chicken is not similar to duck. Cosine similarity and the dot product between the word are 0. Chicken and duck has 0 similarity value. Chicken and I also 0 similarity. So, if we want the vector to be more meaningful, we use what we call the word embedding. With word embedding, chicken and duck should be more similar in comparison to chicken and I. And the length of the vector does not have to be the same as the number of words. With a good word embedding, ideally, we can also use vector operation for relation between words. For example, the word queen minus woman add with man, we should be able to get king vector. This is the ideal. There are many ways to create word embedding, including deep learning based method and traditional machine learning based method. For example, these methods. Transformer itself, they first use byte pair encoding, which is a way to break text into smaller pieces and map each piece to a number or token. But this, like one hot vector, doesn't have semantic meaning. Then, they use a linear layer that is learnable during training, so it produces vectors that are more meaningful. This way, it is probably not the best word embedding. For example, hun-ter is not similar to hungry, but the transformer will know later with self-attention if the hun refers to hun-ter or hungry. Anyway, this method still offers data efficiency and generalization, since, for example, walk, walked, and walking will not need totally separate vectors since all consist of vector walk. Only the ending it and ing can have additional vector to differentiate the meaning. And technically, it is an implementation choice and we can always use other word embedding method if we want. To make the explanation easier in this course, we will consider each word instead of split word. And for other types of data, the idea is similar, which is to convert the input to vectors. For example, image patch input used in vision transformer. We can convert image patch of size height h with W and channel C by flattening it, then use learnable neural network to make the embedding of size D for the transformer.